Right. So for variation of parameters, yes, you first solve the homogeneous.
Yeah.
Okay. The homogeneous, you set the right-hand side equals 0.
Yeah.
So you get y double prime, because d squared y over dx squared is y double prime, minus 2y prime plus y equals 0. Okay. Characteristic equation right away. So that's r squared minus 2r plus 1 equals 0. Factor this, you get r minus 1 times r minus 1 equals 0, right?
Yeah.
So you get r equals 1 repeating. So what is the y complementary, which is the solution for the non-homogeneous, for the homogeneous?
It's
C1.
e to the negative x.
You mean e to the x?
No, I got e to the negative x.
Why? The roots are 1 and 1.
Wait, is it plus or minus?
It's plus. If it
No.
was minus, you can factor it.
Oh yeah. So, yeah. Yeah, r minus 1 times r minus 1.
Yeah. So the roots are 1.
Yeah.
So y equals c1 e to the x plus c2 x e to the x, because it's repeating. Okay?
Yeah.
So that's y complementary. Okay, now we go to the non-homogeneous.
Right.
Okay, now with the variation of parameters, there's, you say, I did one problem where I showed you the complete derivation of the entire process, but on a test situation, you don't have time for all that. You should just go directly to the formulas and figure them out, the U1 and the U2. Okay? So you're going to assume that your Y um, um, particular is equal to Y1U1 plus Y2U2. And usually the way we do this is we take the derivative of this twice, plug it into the differential equation, impose a constraint, get two equations, two unknowns, solve for u prime 1 and u prime 2, integrate them back, we get y particular. But that takes too long on a test situation. You don't want to do that. Those formulas are already derived. I did show you how to get the entire derivation on one of the problems. That it's there and it's also recorded. You can take a look at it. But you know, I wouldn't do it like that on a test situation. I would just go to the final formulas, and let's get those final formulas here. So we can get Wronskian of the complementary solution first. Okay, so we do W equals, okay, and then that's for the complementary solution. So we have e to the x, and we have x e to the x, right? And um, the derivatives, so e to the x, and here you need a product rule. So 1 times e to the x is e to the x plus x e to the x, derivative of the second is e to the x. And you take the determinant of this. So the determinant would be this times this minus this times this. So this will be e to the 2x plus x e to the 2x minus x e to the 2x. These two go away, and we get e to the 2x, which is, of course, never 0. Okay? And now we go straight to the definitions. These, the u prime 1 and u prime 2. So we know that u prime 1 is equal to minus y2 complementary, the second solution, which is this, okay, times g of x. Who's g of x? The non-complementary term in your question. This here is your g of x. Okay? Over the Wronskian, which is a function of x, of course. But that's not here. Okay? And u prime 2 is equal to y1, same, but instead of y2, y1, and there's no negative sign. So g of x over the Wronskian. And now we can just plug them in, integrate each one, find u1 and u2, and that would be multiplied by y1 and y2, and that would be the answer. So if I continue here, let's continue and okay, all right. So then u prime 1, right, is y2. y2 is x e to the x minus x e to the x. G of x is the non-homogeneous term, e to the x ln x, divided by e to the 2x, because the Wronskian turned out to be e to the 2. And you can see that e to the x and e to the x go away with e to the 2x, because you get e to the 2x on top. So that is just minus x ln x. Okay, so what this means is that what this means is that du1 over dx is equal minus x ln x. That's what it means. So we can separate the variables, integrate, and find u1. So that just means du1 is equal to minus x ln x dx. And now I can integrate both sides. Right? Integral of du1 is just u1. You know how to integrate this? Yeah, this needs by parts. Okay, so your u is always ln x, and your du is just x. I mean dv, sorry. Which makes, because integration by parts entails the integral of u dv is equal to uv minus the integral of v du. Okay, so one of those will be the u, the other one will be the dv. So du will be 1 over x ln x, 1 over x dx, the derivative of ln x, and v will be, this is x dx, v squared over 2, because it's the integral of dv. Okay, and now, so from here, we get du1 is just u1 equals minus, and I will apply the integration by parts on x ln x, so it's uv, so it's x squared over 2 ln x minus the integral of v du. So v du, so v is x squared over 2, du is dx over x. And one of those x's cancel out, right? This half I can pull it out, so I would get for u1 minus x squared over 2 ln x. Now, what's the integral of x? Because you have x left here. X squared over 2. And there's another 2, so it becomes x squared over 4. Right? And minus becomes a plus. So this is what you want. And now we do the same exact thing for U2. We plug here and we figure out, we integrate to get U2. So, here I'll change the color here. So U prime 2 is equal to, we said, Y1 is e to the x, right? So this is U prime 2.
It's not homogeneous
What did we say? It was e to the x. Okay. E to the x times the non-homogeneous term, which is e to the x ln x over e to the 2x was the answer. And these two go away. And so we get du2 over dx equals ln x. Separate the variable and integrate. So du2 equals ln x dx. You know how to integrate this? Again, by parts. ln x needs to be, yeah, you don't know the integral of ln x, unless you memorize the formula. So by parts. So again, it's, of course, ln has to be the u. You can't call it the dv because the point is to integrate.
Yeah.
So if you call it dv, you'd have to integrate,
Yeah.
which is the problem.
Yeah.
So u is ln x, which makes du 1 over x dx, and v will just be dx, which makes, sorry, I meant dv is dx, right? Because one is u, one is the dv,
Right.
which makes v to be, what's v? If dv is dx, what's v?
X.
X. Integral of dx is x. Okay? And so now we have du2, the integral of du2 is just u2. No?
Yeah.
Okay. Now we apply by parts here. So uv, so x ln x minus v du. So v is x and du is 1 over x dx integral. And these two go away. And what's the integral of dx? X. So we get u2 to equal x ln x minus x. That means y particular is what? We said it's, remember? U1 times Y1, right? It's actually U1 times Y1 plus U2 times Y2. Right here. Okay? Okay, so U1 we already have. This minus x squared over 2 ln x. So let's write it in red. What's he asking for? General? Okay, well, you need the entire thing. So first we write the particular, then we'll go after the general. So minus x squared over 2 ln x plus x squared over 4. No? Times y1. We call this y1 here, right? A to the x. Plus u2, which we just got right here. X ln x minus x times y2, which is x e to the x. So this is your y particular. And y general is of course y particular, y complementary plus y particular. the one for the homogeneous plus the one for the non-homogeneous. We already have the y complementary, so we can finalize here by writing y general will be y complementary, which was c1 e to the x plus c2 x e to the x plus this, plus e to the x times minus x squared over 2 ln x plus x squared over 4 plus x e to the x times x ln x minus x. This is the general solution of the non-homogeneous linear second-order differential equation using variation of parameters. Got it? Okay, you want to do one? This is the only one on the test, so we will have to go and do one from here.